we're going to talk about actually writing. So I can write linear functions. All right, so, well, that's it for today's lesson. I'm just kidding. Well, not really. This is actually going to be a review, majority for a lot of you, for all of us actually. We've been actually dealing with functions ever since chapter 2. All right, so pretty much what this is saying is, can you graph lines? Can you write an equation from a table, from a graph? And that's it. All right, so a linear function is a function whose graph is a non-vertical line, like we discussed yesterday, right? A linear function can be written in the form y equals mx plus b. Hold up, does that look familiar to you guys? Hopefully. Remember, this is slope intercept form, right? So hopefully you guys recognize this form. Yeah, so this is another piece of evidence that we have been dealing with functions since then. All right, so once again, step 1, right? If I were to find the equation given a table or whatever it is, always find the slope using y2 minus y1 over x2 minus x1, or you can use rise over run. If you're given a graph, if you're given a table, you have to use the slope formula. Doesn't matter which point you use. Nope, as long as it's a function, it really doesn't matter. All right, step 2, identify the y-intercept. All right, so remember, how did we figure out the y-intercept? Oh yeah, this is always when x equals 0. So right, so if I were to take a look at this one, it is always at this point right here. That's my y-intercept. So that's what I can do. And then step 3 is plug it into slope-intercept form. As we said earlier, y equals mx plus b. That's it. All right. So let's do this first example together. Use the graph to write a linear function that relates y to x. So step 1, let's find the slope. Oh, why can't I write? All right, I'm going to use a different color. I'll use rise over run. So I'll go up 1, 2, 3 over 1, 2. So 3 over 2, just in case I'm going to check my work. So up 3 over 2. All right, so that means I counted correctly. So my slope is going to be m equals 3 over 2. Y, step number 2, let's take a look. It's identify the y-intercept. Remember, this is when x equals 0. So is it going to be this one or this one? It is going to be this one. Why? Because it's when x equals 0. This is when y equals 0. So this is going to be my y-intercept. All right, so b is going to be equal to -3. Step 3, plug it all in. So I have y equals 3 over 2x minus 3, or plus -3, or minus 3 it's the same thing. I would leave it as -3. All right. Now, same thing using a table. Let's figure this out. So it looks like step 1, find my slope. So x1, x2, y1, y2. Actually, let's move this over. I don't want to use negatives, or I'd rather use at 0. So 3 minus 5 over 0 minus a -1. Please be careful with your negatives. So I have -2 over 0 minus a negative becomes a plus. So 0 plus 1 is 1, which is -2. Step number 2, if you ever forget, always use your notes, is identify my y-intercept. This is when x equals 0. Boom, right here. B is equal to 3. Step 3 is plug it all in. So y equals -2x plus 3. So a question may come, will there always be a 0? And when we deal with functions, yes, there will always be a x equals 0 like here, x equals 0 like here, and then in this one you're like, well, there isn't an x equals 0, but can you move back to figure out when x equals 0? Yeah, look, what's the pattern here? -2, minus 2. So next one is going to be 0. What's the pattern here? Minus 600. Minus 600. So this next one is going to be 0, right? So even though you're not given a 0, 0 or 0x value, you can always figure it out from the context of the problem as well. All right, so here's the last word problem. Last example we'll do for today. So write a linear function that relates y to x. So same kind of thing. So step one, if you let's see if you remember, is to find the slope. Okay. I'll use 1200 minus 600 over 4 minus 2. So I get 600 over 2, which I get 300 as my slope. Step 2 is my y-intercept. So this is where you have to figure it out, right? So you have to plug it back in. No, excuse me. This is where you have to figure out what x equals 0. And yes, you will always be able to figure it out. Even in the your turn on your own word problem as well, there is a pattern for you to figure it out, right? The next one is going to be at 0, right? This may not be at 0, but at least your x will be at 0. In the end, that's all that matters. All right. So at b, so let's figure my b is 0. So my step 3, writing the entire equation out, y equals 300x plus 0, but I don't even need to write the plus 0, so I could leave it just like that. All right. Oh, and it says, I didn't even read the problem. It says graph the data in the table. All right, so let's graph it. So my x is going to be, according, it says hours kayaking. And my y is going to be calories burned. All right, so I could go up by 0, 1, 2, 3, 4, 5, 6, 7, 8. 8 is my max, and that's where it gets a little hard. I can't go up to 2,400. I think I might go off this page if I wanted to go up by ones doing that. So let's go up by 300s. Yeah. So if I go up 300, 900, 1200, 1500, and 2400. All right, so now let's plot these points. It looks like 2, 600, 4, 1200, 6, 1800, and 8 is 2400. So I just plotted those points. That's all you have to do. And then, yeah, let's draw a line down the middle. Boom. And does this make a function, yes or no? It is a yes. Why? Because it passes the vertical line test, right? I could put any vertical line on here. It'll always pass it. All right. So how many calories do I burn in 4.5 hours? So this is where you have to use the equation that we just solved for, right? So you see how we have y. Whoops. I have y equals 300x. So 4.5 hours. Hours, is that my x units or my y units? It is my x units. So what do you think I'm going to substitute in 4.5? I'm going to substitute it in for my x. So I have y equals 300 parentheses 4.5. That means I'm going to multiply. Quick way to do this is like 300 times 4, right? Which is, that's pretty simple. Plus 300 times 0.5. Well, you're multiplying by half, which is 150, right? Half of 300 is 150. You could add these two up and you get 1350 calories. All right. So just be careful with what units you're plugging them into, because if it said how many hours does it take for you to burn like 3,000 calories, and you'd plug in 3,000 for y and you would solve for x, right? So just be very careful with what you're doing here. So why don't you guys finish on your own, and then if you need help, like look back at these notes to help you out. You can replay any part of this video as well, fill out your level of understanding on Edpuzzle, and then we'll start our homework the next day. All right, good luck.